We're going to talk about how to find area between curves. But now we're going to integrate with respect to y. So we're going to look at this through the following example. Let's find the region, the area of the region bounded by x equals square root of y and x equals y. So you can hopefully tell that this problem is a little bit different than the ones we've looked at. Look at our equations. They're solved for x instead of y. But we're going to repeat our process that we've been doing. So the first step, first find the intersection points. So we're going to set these two equations equal. They're both solved for x, so square root of y equal to y. And now we're going to square both sides to get rid of our square root. Move all our terms to one side. And then I can factor out the y. And I get two solutions. I get y equals 0. And I get y equals 1. Now if you take either one of these and plug them into either function, you'll get the actual points of intersection 0, 0, and 1, 1. So I need to know which function is on top of the other and between. I know that they intersect at these two places, but I need to know which function's on top and which function's on bottom. So we're going to plug in a y value between our two y values here. So between 0 and 1, let's plug in y equals 1/2 into our two functions. So for x equals y, if we plugged in y equals 1/2, we'd get x equals 1/2. So I get the point 1/2, 1/2. Okay. And this line is just it's a straight line. So I can sketch that. And now let's plug in into x equals square root of y. So x would be 1 over the square root of 2. One over square root of 2 is bigger than 1/2. So our x coordinate is a little bit bigger. But with the same y coordinate. Okay, so here's our region. Because we're integrating, because everything is in terms of y, really, it makes sense to integrate in terms of y. And so instead, I'm going to think horizontally instead of vertically. You're going to do the right function minus the left function. So normally it's top minus bottom. That's when you're integrating in terms of x. But now you're going to think about right minus left. Okay. So our area here, the integral, if we're integrating in terms of y, this would be the formula you would have, f of y minus g of y. And again, the first function would be the function on the right, and the second one would be the function on the left. All right, so let's find the area here. which function was on the right? It was the square root function. So it would be the integral of the square root of y minus y. And then y, what were the bounds on y? It went from 0 to 1. Okay, so then you compute this, integrate, do your reverse power rule here. So you would get 2/3 minus 1/2. If you get a common denominator, that would be 1/6. So that's how you integrate with respect to y. Now, if you wanted to, you could do this problem integrating with respect to x. You just have to take your functions and solve for y. Integrate with respect to x. You take your two equations, so if you square both sides here, you'll get y equals x squared, and here it's already solved for y equals x. So if you wanted to find the area here, it would be top minus bottom. Remember that the line was on top, so x minus x squared. And x also went from 0 to 1. And you should get the same answer that you got when you integrated with respect to y. So you would get x squared over 2 minus x cubed over 3. One half minus 1/3, 1/6. Again, that's the same answer you got before. So for this problem, you could either integrate with respect to x, you do top minus bottom, or you could integrate with respect to y, right minus left. Okay. Because the problems were given to you in terms of, the functions were given in terms of y, I would probably integrate with respect to y here.